Hi, this is Chris, and we are continuing with questions 9 and 10 in section 3 of SAT Practice Test 2. So let's take a look at number 9, which reads, the graph of a line in the xy plane has slope 2 and contains the point 1, 8. The graph of a second line passes through the points 1, 2, and 2, 1. If the two lines intersect at the point A, B, what is the value of A plus B? Okay, so first let's see if we can get a visual on what this is going to look like. So here, if we have a coordinate plane, then we can go 1, 2, 3, 4, 5, 6, 7, 8. So 1, 8, and put a point there. And then a slope of 2 means that it's going to go up 2 over 1 or down 2 over 1 the other way, which would cross the y-axis here at 6. And then it would be here at -1, 4, and so forth. And we can draw a line. It might not be perfect, but it at least gives us a ballpark idea of where we are. And then for the second line, we have points 1, 2, which would be right here, and 2, 1, which would be right here. And so we can connect those and extend that line, and again, might be a little bit imperfect, but it at least gives us a visual so that we can label things accordingly as we go to solve. And it says that they intersect at the point A, B. Okay, well, if we can come up with an equation for each line, then we can set those equations equal to each other to figure out the exact point, because we don't want to ballpark it in case we're off. At first glance, we might say, oh, well, this point of intersection here looks sort of like it's at an x value of -1 and maybe a y value of 4, or, kind of close to, 4, but it's not exact because our picture that we draw ourselves isn't perfect, which it's not expected to be perfect. We need to use the equations to confirm. So let's see if we can use these equations to confirm. So for the first line, we said that we cross the y-axis at 6, which was this point right here. And we know the slope is 2. So for that first line, we're able to write out a slope-intercept form equation for the line, which is y equals 2x plus 6 in the form mx plus b. Now, for the second line, we have a ballpark idea looking at it, but let's see if we can confirm. So if we find the slope between these 2 points by doing what we did on another question earlier in this section, which is just y2 minus y1 over x2 minus x1, we can do 1 minus 2 over 2 minus 1. And that'll be -1 over +1, which is just -1 for our slope. So if we know the slope is -1, now we can count off the exact point of where we cross that y-axis. So here, that means that we are going down 1 over 1 in this direction, or the other way, you can go over 1 to the left and up 1. 1 to the left and up 1 means we are crossing the y-axis right at 3. So that's enough for us to use our slope and our intercept to come up with an equation for that line. And when we have these two equations, since they're both in slope-intercept form equal to y, we can set those two equations equal to each other to confirm this point. And so here we would do 2x plus 6 equals -x plus 3. Add x to the left side, subtract 6 from the right side, we get 3x equals -3. We get x equals -1, which, hey, that's about what it looked like, but we didn't want to guess. We wanted to confirm. And so here, when x is -1, you could plug that back into either equation, and that would give you -2 plus 6, which is +4. So now we know this coordinate for A and B. That coordinate is -1, 4, and when we add those together, we get 3 as our result. So on a question like number 9, it's supposed to start getting tough here. So if you do want to ballpark it and see if you can draw out your graph accurately and eyeball it to come up with a guess, then that's certainly a strategy that might lead you to the correct answer. But if you want to be sure, especially on a slightly more difficult question, and use the equation route, that's how you can confirm the exact value is in fact 3 for the sum of a and b on this. Now let's take a look at number 10. Which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? So basically what they're saying here, and I'm going to try to draw a graph for each of these. So let me make a couple of coordinate planes, see if we can squeeze them into this space. Because it is important that we know some of these parent functions, because they'll show up a lot. So we're going to see if we can draw graphs for a, b, c, and d. Okay, so here they're really testing our knowledge base of what these parent functions look like, and then understanding the appropriate types of shifts that we have when you have a transformation in a graph that is maybe moving it left, right, up, down, etc. So here for A, the graph of y equals absolute value of x. So if we ignore the -2 for right now and cross that out, but y equals absolute value of x will look basically like a v. So absolute value of x would look something like this. And then when you have that -2 afterwards, this is going to be a vertical shift down 2. And my little mnemonic for that is whenever you're trying to figure out what types of transformations you're going to have, I think of it as HIT, which stands for horizontal, inside, tricky. And what that means is if you have something inside of parentheses or inside of a root, kind of like we do in answer choice C, that's going to indicate a horizontal shift. And horizontal shifts are a little bit tricky because they work almost counterintuitively. A -2 is actually a shift to the right by 2 units. So you're going to the right 2. You might think minus would indicate a shift to the left, but that's why the horizontal ones are a bit tricky. So HIT, horizontal inside tricky, is a great way to remember what type of transformations you're going to have for your graph. And then here for A, since it's not inside the absolute value or inside parentheses, that's going to indicate a vertical shift. And in this case, vertical ones are a little bit easier because it works more intuitively. -2 means down 2. So it would be this original V shape that we see here, but it's going to be that same V shifted down 2 units. So your V will come to its point here at -2. And let's check how that relates to the question being asked. Because remember, they wanted a graph where the y is always greater than or equal to -1. So if we put a little dashed line here at y equals -1, we want a graph that's always above that line. And we can see for A that that does in fact drop below that line. So we would say no thanks to answer choice A. Now let's try B. Again, it's important to know our parent functions. So y equals x squared is a graph we should memorize. And that's going to be a parabola that has its vertex right at the origin. So that would look just like that without the -2. And now when we factor in the -2, let's see how that's going to change our graph. And basically, what it's going to do is shift our graph down 2 units, kind of like what we saw in answer choice A. So this vertex now would be at -2. And if we draw in our horizontal line at y equals -1, we can see that this graph also drops below that point. So we can go ahead and eliminate answer choice B. Now for C, we already talked about what type of shift that indicates when it's inside parentheses. So that's part of our HIT acronym, horizontal inside tricky. So it's inside parentheses. It's going to be a horizontal shift to the right 2 units. So that would be this same parent function, that parabola with a vertex at the origin. And then the -2 inside parentheses shifts it to the right 2 units. So you would have a parabola that crosses the x-axis at 2. And if we look here, put in that horizontal line at y equals -1, and we can see that our graph does stay above that line for the entire graph, which means that C is in fact going to be our correct answer choice here. That shows values for y that are always greater than or equal to -1. And just to finish it out for D, your parent function for x cubed is going to look kind of like an S. So y equals x cubed would look like this. And then we have a -2. It's not inside parentheses, so that's going to be a vertical shift down 2 units. So this S-shaped graph would cross the y-axis at -2. And as we can see here, it does in fact drop below that y equals -1 value. So we would be able to eliminate D as well. But on this particular question for number 10, it's really important for us to really know those parent functions very well. You should know graphs for y equals x squared, y equals x cubed, and y equals absolute value of x. Those 4 are essential for test day success. Up next, we'll cover questions 11 and 12. Thanks for watching.